Let's talk about hash maps. Imagine you have a huge bookshelf like Hogwarts Library. If you have seen Harry Potter, you will know it. So let's say you have got a new book and you need to find a spot to place it in that huge library, okay? And later on be able to search it quickly every time you need that book. So what you would do, you might go and scan the whole shelf, a whole library to find that book. Also, would you do it? Is it efficient? No. So instead of scanning the whole shelf, what you would do is to use a magical spell that tells you exactly where to place or find that book. This magical spell takes the book's title and gives you a specific location, like fourth shelf in the 10th spot. But remember, even if you slightly change the book's title, this still gives a completely different spot for that book. Okay, so now let's map this to our computer science. So when you talk about hash maps, there are many concepts like hashing, hash function. So first of all, what is hashing? So basically, it's a technique that takes an input, which you can say a string or a message, okay, and it returns a fixed size string, which looks completely random. The output known as a hash value, okay. So this hashing value takes in a message and returns a hashed value of that string, okay, which is mostly unique to the given input. So then comes to the hash function, okay. So what is hash function? Okay, so this is our magical spell. What it does is it converts the input data, like our book title, into a fixed length value. As you know, no magic is perfect. If two different inputs give the same hash, that's called a collision. Okay, collision usually occurs in the hash map. It's like our spell accidentally pointing to the same spot for two different books. Now, the good hashing function algorithm makes this super rare. Okay, so there are like some main elements of hash map, which are basically the keys, values, the hash function that we just discussed, and buckets. Okay, so what are keys? Okay, so in our library analogy, so think of keys as the unique identifiers for each book. Keys are the inputs that we feed into our hash function, okay, and they can be any data type, like it can be primitive types, or it can be non-primitive types like object and arrays. It could be numbers, strings, okay. The crucial characteristics of keys is that they could be unique, they should be unique, okay. If two pieces of data share the same key, it might lead to complications like collisions. And the second main element is values, okay. So the values are the actual data that we store in our hash table, okay. They could be anything from a single number to a complex object or even a function. Using the key, we can quickly retrieve the corresponding value from the hash table, okay. Now comes to the hash function that we just discussed, okay. So let's touch on this, okay. Before it's worth emphasizing the importance of hash function. This is the engine, okay. So this is the engine that drives a hash table, okay. So it's responsible for transforming keys into hash values, which dictate where we store our data in our table, okay. So the fourth element is buckets, okay. Once the hash function processes our all the keys, it produces a hash value, okay. This value corresponds to the specific location or bucket within the hash table. You might call it a bucket or a specific or a location in the memory. Think of buckets as shelves in our library, each one designated to store a specific book or a piece of data. So the time complexity when it comes to the hash function usually are big O of one. Like the insertion is big O of one, and the searching could be big O of n, and the deletion is big O of one, and okay. So the insertion, searching, deletion, and getting a particular value could be big O of one as well. That's why it's considered an efficient data structure. So if you want to know more about the hash maps, I will leave a link so you can go and read more about the hash maps. This video is not about hash maps from the scratch. So I will be just solving problems using the hash map data structure. You will see it. Let's just comment this out. So the first problem that we have is first non-repeating character. Basically, this function takes a string and you need to find a character that is not repeating, which is a unique, but it's the first value that is not repeating. So in this example, you can see the ABCD. Okay, so here A is the first non-repeating character because A is not repeating in the string again. Okay, so in this example, so A is repeating, as you can see it. A comes before the B as well. So here the B is the first non-repeating character. Okay, so in this example, R is the first non-repeating character because sorry, F is the first non-repeating character because F is not repeating in the string again. So let's just code this solution and let's brainstorm this problem, how we would approach this problem using the hash map. Okay, to solve this problem, we will use a hash map. So keep a record of each character in the string and the number of time it appears. Okay, so what we will do is first we just iterate through the string and then we will populate the hash map with each character as the key and its frequency as the value. Then go through the string again. Okay, this time we will be checking each character against the hash map. Okay, so the first character that has a frequency of 1, which indicates it doesn't repeat, okay, in your target. This character is the first non-repeating character in the string. Let's say if no such character exists, the solution should indicate that as well. But this two-pass approach ensures efficiency as each character is checked against a pre-compiled frequency map. Okay. So let's just create an hash map. We call it frex because this is storing all the frequencies of each character in the string. So let's just traverse through the string using the for of syntax in JavaScript. So let C of str, the C is the each character in the string. Okay, so let's just say the frex of C is equal to frex C if it's appearing first time, its value should be 1, and if it appears again, then it could be 1, and the 1 plus 1 will keep incrementing its frequencies. Okay, so this is how we are storing the frequencies of each characters. Now we just loop through the string again. So let's say okay, so we have our hash map. So let's just loop through the hash map using the for of. So at value of, we can use the object values and passing in our fracs. Object at values returns the values inside the fracs hash map. So each value is the frequency of each character. Okay, so if the value is 1, this means this character appeared only one time. Okay, so if the value is 1, we could just simply return this but no, we need the index. Okay, so we can return just this character. Okay, so the how do we return the character, because this is the value. So instead of looping over this using the object at values, we could use the traditional for loop. So we could say this say str dot length, and we just do plus plus. Okay, so if say the fracs of character at stri, if it has the value 1, this means it appear only 1, so we can just return this character. Else we will just return -1 because there doesn't exist character which appear only once. So let's just run this using the node file name command. Okay, so we also need to print these as well. Okay, let's just comment this out and see. So the a here is the first non-repeating character in this input, so this is correct. So let's just check this for input. So here b is the first non-repeating character and here f is the first non-repeating character, right? Let's run this again. So for the first example, the output is A, and for second it's B, and for third it's F. Okay, so it's completely working. So the time complexity of this algorithm will be because we are traversing through the string, which it is big O of n, and this is also big O of n. So uh, it's the time complexity of the algorithm is big O of n, and we are also maintaining hash map, which is also big O of n, because we are storing each character in this flex. So the time complexity and the space complexity is